to another session, another review session of the material that we've talked about so far this semester in college algebra. All right, so today's topic is going to be about graphing linear equations. And the first thing that I want to do is I just want to do basically an information dump about all of the stuff that we've talked about, all of the stuff that we've covered related to linear equations. Remember, when we talk about linear equations, these are equations that will yield a line, a nice straight line whenever we graph. Okay. So the first form that we see, the one that we like to use a lot, is the slope-intercept form. So the slope-intercept form is y equals mx plus b. So some things to note about this form. First of all, in this form, this is an equation. It's an equation that is already solved for y. If we have that, then here's what we're going to do. We can pick off this coefficient right here, that guy that's connected to the x, and this becomes our slope. And if you guys remember, a lot of times when we talk about slope, we talk about rise over run. Okay? And then we have this guy that's here at the end. And this leads us to our y-intercept, which would be the ordered pair 0, b. Now what you need to understand is that b itself is not the y-intercept. The y-intercept, as we're going to talk about here in just a moment, the y-intercept is the point where the line crosses the y-axis. So it's a point. And as we know from points, points must be given as ordered pairs. Okay? And again, we're going to talk about the slope here in just a moment as well. So that's one of the big forms that we have, is the slope-intercept form. And then we have the standard form. Okay? And the standard form looks like this. ax plus by equals c, with the conditions that a, b, and c, a, b, and c are real numbers, and a and b are not both 0. A and b are not both 0. Okay, so as we think about what that means for us, if a and b were to both be 0, that means we would have 0x and 0y. We wouldn't have any variable terms there, which means we wouldn't have the line. We wouldn't have anything. So it would just be non-existent. So one of them could be 0, but they can't both be 0 for those coefficients. Okay? Now, these are the two major forms that you're going to see when we're talking about graphing linear equations. They each have their own usefulness. This slope-intercept form is great for identifying the slope and finding out the y-intercept. The standard form is really best if you are tasked with finding the x and the y-intercept. It's pretty easy to get from this standard form. Okay, so we're going to go through some examples so you can see how to use which form, which one works best for us. But before we get there, there's still some more information that we need to get out. Okay, when we talk about your slope, above we mentioned that the slope is the ratio of rise to run. And the rise just means how you are changing in the y direction, and the run indicates how you are changing in the x direction. Okay. Now, a lot of times the way we represent this is that when we're talking about change in y and the change in x, we'll use this little triangle symbol. And this is actually the lowercase Greek letter delta. So you might hear delta y over delta x. Anytime in a math or a science class you see delta, this little triangle, that typically means change. So the change in the y versus the change in the x. And so that ratio of rise to run, is going to give us our slope. So the formula for our slope, and a lot of times we use m to represent our slope is going to be the change in y over the change in x. Now when we do change, we're talking about finding the difference, which is why you see the subtraction here. So to find the change in y, it's the difference from the second y coordinate from the first one, and then the change in x is the second x coordinate minus the first x coordinate. That's what those little subscripts mean. It's just to denote between the first and the second x and y coordinates. All right, so that is for our slope. Ooh. Excuse me. So let's talk about what it means to be an intercept. So the x-intercept, this is the point. It's a point where the line crosses the x-axis. Now, when we do this, every x-intercept is going to look the same. Every x-intercept is going to be of the ordered pair. It's going to be of the form a, comma, 0. And we have a very similar definition when we talk about the y-intercept. So the y-intercept is a point. It's the point where the line crosses the y-axis. And every y-intercept is going to take on the form 0, comma, b. Okay? So, if we were trying to find the x and the y-intercepts, something we already know from the very beginning for each of them is that for x, the y-coordinate is 0, and for the y-intercept, the x-coordinate is 0. So as long as we remember that, then we're going to be okay. There's one last little guy to talk about here. And this is really more important for our discussion tomorrow. Now, a lot of people use this form a lot, this formula. I tend to use it very rarely these days. And that's the point-slope formula. So the point-slope formula is going to be this: y minus y1 equals m times x minus x1. And so what you're doing here is that you are plugging in the slope that you're given, and you can plug in an ordered pair, x and y. And what this is used for is the information we're going to see tomorrow, where we are writing equations of lines. And so if I tell you, here's the slope of a line, here is the a point on the line, you could take the slope in the ordered pair and just plug it in. It's going to tell you what the equation is. Now, I used to use this all the time, but I use it very rarely anymore because I find there are easier ways of finding equations of lines. And again, we're going to talk about that tomorrow, so come back again tomorrow at 3, and we can review that information as well. All right, so what we want to do now is just kind of go over, graphing lines. Some of those basics that we've seen before. Put some of this stuff in the graphing calculator as well, because why not? All right, so let's look at y is equal to 2x. Y equals 2x minus 3. please note that this is in that slope-intercept form because it's solved for y. We have the x term written first, followed by the constant. And so you can directly see how things match up to that slope-intercept form. So from here, we see how the m, which represents our slope, is 2. So the slope is equal to 2. Now remember how we were saying the slope is a rise over run? We like to look at this as a ratio or as a fraction. So the easy way to do that for something like this is to say that this is 2 over 1. And then we look at this constant here at the end. And the constant at the end directly relates to our y-intercept. So we see -3. So it gives us the ordered pair 0, -3. And with these two pieces of information, we have all that we need to accurately graph our line. You need to understand what each of these pieces of information will do. The slope tells you how to move from point to point. So we can't use that yet because we don't have any points on this grid, except for the y-intercept. See, the y-intercept is a point, and we know that we have that guy for certain. So 0, -3 is right here. Now remember, if you have a hard time remembering where points are supposed to go, make sure that you label your axes correctly. This is the x-axis, and that's the y-axis. So every x-intercept is going to go on the x-axis, every y-intercept goes on the y-axis. Now, you may be wondering, how do I know that it's 0, -3? Well, in order for us to be on the y-axis, the x-coordinate must be 0, because if the x-coordinate is positive, you're over here. If the x-coordinate is negative, then you're over here. But the only time that you are actually going to be on that y-axis is when x is equal to 0. So we know that for certain. And if you plug 0 into this, 2 times 0 is 0, and 0 minus 3 is -3. So when you plug in 0, that guy goes away and you're left with -3. Now, your slope. Your slope we wrote as a fraction, and we know that this can be interpreted as rise over run. So it's going to tell us how to move from point to point. It tells you how to go up or down and then left or right. So from here, we're going to go rise of 2, so that's up 1, 2, and then a run of 1. Now it's a positive direction, which means we're going to go to the right. So over here. And we can keep going in the same pattern to get more points. So go up 2, to the right 1, up 1, 2, to the right 1. And we keep on doing that until we get to the edge of our graphing window. Now we've got some more points that we can graph by going to the left. So go down 2, and to the left 1, down 2, to the left 1, and so on. Now if you think about what I was saying to go down 2, so that means a rise of -2, and go to the left 1, which indicates a negative one because we're going to the left. If you simplify this fraction, it still reduces to +2. All right? And now we just use a ruler to draw a nice straight line. Now, you don't have to use a ruler with all the points that we have here. It should be easy enough to connect these dots. Remember that when you graph, you should go edge to edge of your graphing window. And you also want to make sure that you put arrows on the ends to indicate that it goes on forever in both directions. One thing that I do want to point out here is why we graph. It's like the same reason that we did all of the stuff last week when we had equations. We were solving equations to find the replacements of the variable that made the equation true. When we graph, the graph is a visual representation of all of the solutions to this equation, which means any ordered pair that you see on this line, not even just those nice ones that we found that had nice integer coordinates, but any point on here, you could take that ordered pair, plug it in for x and y, and it would give you a true statement. So let's make sure that we have that written down so we understand the purpose of the line. So the purpose is what the line represents. The line represents all solutions to the equation. So we didn't have a way to write all of the solutions, write all of the ordered pairs that would work for this equation. That's where the graph comes in. It's just like trying to graph things on a number line when you're dealing with inequalities. It's a visual representation. Now, when you're doing a number line, you can then convert that to interval notation and say, here it is. You don't have to look at a picture, it's just right there. When it comes to graphs, we need a graph, right? The graph is showing the solution set for that equation. All right, so let's try another. So if I look at y is equal to negative 3/5 x plus 2. Please note again that this equation is already in slope-intercept form. And the reason we know it's in slope-intercept form is because we already have y by itself. And since y is by itself, we can identify the slope. So the slope is negative 3/5. One of the key things to understand here is that even though the slope value, the number that we're looking for, is connected to x, the slope itself is just a number here. Okay? For these lines that we are graphing, the slope is staying the same. The rise to run, that ratio is going to be the same no matter what. So if we go back to this last problem that we had up here, it doesn't matter what 2 points you pick. If I go from here and I go up to this guy and I try to calculate the slope, from here to here is a rise of 6 over a run of 1, 2, 3. And that still reduces to a slope of positive 2. Okay? So, the slope is just a number. Now, if you want to talk about the slope having a variable component to it, that's more of a calculus concept, so we're not going to talk about that here in this video. Okay? So, the slope is only that coefficient. Your y-intercept comes from this constant here at the end. So it's the ordered pair 0, 2. And with these two pieces of information, we can graph our line. Starting, of course, with the y-intercept. Always start there. So 0, 2 starts right, oh, not there, that's negative 2. I got to pay attention. 0, 2 is right here. And now we use the slope to get extra points. So this is a negative slope. And what that tells us is that from left to right, our line is supposed to be going down. It's supposed to be decreasing. So from here, go down 1, 2, 3, and then go to the right 1, 2, 3, 4, 5. Right here. Because you have a single negative that you can use. So you can look at this as negative 3 over 5, or you can look at this as 3 over negative 5. One or the other. You only have one negative sign, so you cannot apply it to both. Okay? And you saw from above that if you had a negative in the numerator and denominator, that just becomes a positive value. And you see that with a positive slope, your line is increasing as you go from left to right. All right, back to this guy. Let's try to do the slope again, going down 3 and going over to the right 5. 1, 2, 3, 4. It's off the grid, but just by one little unit, so I think that's going to be okay. We can get more points by reversing and going up and to the left. So go up 3, and now go to the left 5. So by going up 3 to the left 5, that's looking at it in this form. A rise of 3, going up 3, but a run of negative 5, so going to the left 5. And we can do that again. Up 3 to the left 5 is going to be somewhere right about there. Then we can take our nice straight edge and connect the dots. All right, so something like this. Very satisfying. And there you have it. So between any 2 points on this line, once you simplify that ratio, that slope is going to be negative 3 over 5. Okay. Also, any point that you can identify on here is also going to be a solution to that equation. Again, that's why we graph. the graph is the visual representation of the solution set to that linear equation. All right. Let's keep on going. I mean, I've got a whole stack of paper. Might as well keep on going until I run out. All right, so now, if I look at 4x minus 3y equals 3. Now, this equation is in standard form, but I want to be able to find the slope and the y-intercept so that I can graph it hopefully fairly easily. Okay, so in order for us to do that, we have to solve this equation for y. So step by step, we're going to take our steps and get y by itself. So get this guy by itself. The first thing we do is to move the 4x to the other side. Now I know the order of the terms doesn't really matter, but I'm still going to write this so that my variable term is first. That's what we're used to seeing for the slope-intercept form. It goes y equals mx plus b. Now don't think that this is in slope-intercept form just yet. We still have to finish solving for y, which means divide by that coefficient. Divide everything by -3. Make sure that you are showing the work like this. Step by step, you're going to be fine. If I'm dividing this by -3, everybody else gets divided by -3 as well. This leaves us with just y equals. And we just got done talking about this. Negative divided by negative is positive, so this becomes a positive 4/3 x. 3 divided by -3 is -1. Now that we are in slope-intercept form, we can clearly identify our slope because that's the coefficient of x. Our slope is 4/3. And the y-intercept is not -1, but it is the ordered pair 0, -1. Armed with that information, we're going to go to the graph. So starting with the y-intercept, which is at 0, -1, get this guy right here. The slope is positive, which means my line should be going up from left to right at a rate of 4 to 3. So go up 4 units to the right 3, up 4 to the right 3. And let's get more points. Let's go to the left side. So to do that, we're going to flip this around. And instead of going up and to the right, we're going to go down 4 to the left 3. Down 4 to the left 3, just like that. If you are using the slope correctly, you should be able to take your straight edge and line these points up, and there shouldn't be anything weird going on. Now, if you find the points are off by just a little bit, go back and check to make sure that you did count correctly. I've seen it many, many times where students try to use the slope and they instinctively want to start from the origin. We can't do that. We have to start from the point that we have. Also, you want to make sure that your y-intercept is plotted on the y-axis. I've also seen students do this. When they try to count from here, they go 1, 2, 3, 4. But that's, you haven't even moved yet. So that's going to be where 0 is, and then you count 1, 2, 3, 4, and over 1, 2, 3. Now I said that any point that's on the line should be a solution to the equation. Okay, so let's look at this guy right here. This is the ordered pair. Let me see, that is 6, 7. Now I maintain that this is going to be one of the many, many solutions that we have for this equation. So it's worth our time to plug it in to check to see if it works out. Okay, so let's just check this real quick. That's going to be 4 times 6, because that's x, minus 3 times 7. I get 24 minus 21, which equals 3, and that's what I was supposed to have on the right side of the equation. So it does check out. You could pick another point somewhere over here just to verify that what you have is good. Okay? All right. Now the next examples that we want to look at will involve identifying and calculating the x and y intercepts and using those guys to help us graph. Alright, so let's take 3x plus 2y equals 12. So for this problem, I want us to identify the x-intercept and the y-intercept, and then use those 2 points as the primary source for graphing this line. Now, before we get started, let's talk about what we already know about every x-intercept and every y-intercept. For every x-intercept, the y-coordinate is 0. And for the y-intercept, the x-coordinate is 0. Like, we know these guys. We can't really get away from that. If for the x-intercept you try to tell me that the y value is something other than 0, that would mean that you are either above or below the x-axis. But you have to be on the x-axis to be an x-intercept. Alright, so let's see what we're going to do with this guy. And this is actually quite simple. You might see textbooks and other teachers say you got to make it really, really complicated. No. See, here's the thing. If y is 0, that means that when you do 2 times 0, you get 0, which means that guy just goes away. He's not even there because you plugged in 0. And so what's left over is this nice little equation. That 3x equals 12. And we know that if 3x equals 12 and you divide both sides by 3, you find out that x equals 4. And so there you go. That's all we have to worry about doing. And then we flip this around and we say for the y-intercept, if x is 0, so if x is 0, then the x term is now gone because you plug in 0, 3 times 0 is 0. And what we're left with is the equation 2y equals 12. And if 2y equals 12, y equals 6. And so this is how we complete those ordered pairs for the x and the y intercepts. With that information in hand, we can now get to graphing this. Remember, every x-intercept goes on the x-axis, so 4, 0 is right here, and then 0, 6 is going to be up here. Now we would like to find more points. I mean, you could just throw the ruler on here and hope that you're going to be okay, but turning it just a little bit, if you don't line these points up just right, you're going to be off. I'm the kind of guy who's going to be looking for all of the points to make sure that things line up correctly. So let's talk about what the slope is for this. My slope is, as always, rise over run. So as I go from here to this point, I'm actually going down 6 for my rise, but my run is going to the right, so that's positive 4. So that is my slope. But we can do better than that because we can reduce this fraction. When we simplify this, we end up with a negative reduced by the common factor of 2, and we get 3/2. Now watch how this gets put into action. If I go from here, I should land at this point as long as I follow the slope. So go down 3 to the right 2, there should be another point. Go down 3 to the right 2, and there I am, back on the x-axis. Back for my x-intercept. So let's keep doing this. Down 3 to the right 2, down 3 over 2, down 3, and just a bit off. Okay? And we can go up 3 to the left 2 to maintain that pattern. Now, if you had just used these intercepts, and you'd said, okay, well, I'm going down 6 over 4. If you go down 6 over 4, you land at this point. But by simplifying and reducing that fraction, it allows us to get more points, which improves our accuracy. So, there we go. Now, if you wanted to check this in your graphing calculator, the problem that we run into is that the graphing calculator requires you, for the most part, to have your equations solved for y. You know what? So let's do that. Let's take this and let's solve it for y, just to make sure that A, we can, and B, that it checks out with what we already have for this problem. All right, so 3x plus 2y equals 12. When we solve this for y, the first step is to move the 3x to the other side. The more of these you do, I'm sure, the less you're going to be writing the subtracting 3x on both sides. And you're just going to do it. Just move it in your head. So that's negative 3x plus 12. And divide by this coefficient of y, so divide everything by 2. We end up with negative 3 halves x plus 6. So from this form we can identify that my slope is negative 3 halves, and we can identify that the y-intercept is 0, 6, which the 0, 6 is what we already identified from before. The slope of negative 3 halves is what we were able to find by looking at the ordered pairs for the x and the y intercepts. So everything checks out. It's fantastic. And now, let's see what this looks like on the graphing calculator. All right. So on the graphing calculator, if you want to graph, you just press y equals. Now it gives you almost an unlimited possibilities for the equations that you can type in. But notice that they all say y equals. So for us, we had to do some manipulating, right? And we came up with y equals negative 3 halves x plus 6. So negative 3 halves x plus 6. Please make sure that you are using the correct button for the negative, in case you guys have forgotten. This is negative, and that's what you're going to use when you have a lead-off negative in your expression, and you want to put that into your calculator. This minus sign that you see right here requires something both before and after it, just like addition, multiplication, and division will. If you, over here instead, notice the difference. If I use minus instead, it's more right in the middle, and it's a little bit wider. If you use the symbol, the calculator is going to say there's a syntax error, which means you type something in a way that it doesn't understand, or a way that it's not expecting. So let's make sure we change this back to the negative. And then we can just press graph. And here is our graph, which you will see is pretty much the same thing that we have here. Now it may look a little bit different because of the way the scale is. Even though each tick mark here is representing one unit, the graph is not a perfect square. So it's being stretched out a little bit horizontally, which gives you this, slight difference between what we graph by hand and what the graphing calculator does. Okay. Anyway, that's what we have for using the graphing calculator. And you can go back and check the other guys as well to make sure that they are all doing what they're supposed to do. All right, let's take a look at negative 2x plus 5y equals negative 5. And just as we did in the past, let's go ahead and solve this guy. Nope, I'm jumping ahead of myself. I was going to say solve for y, but I want us to find the x and the y-intercepts like we did before. All right. And again, like with all good things, you start with what you know. So what we know is that for the x-intercept, y is 0, and for the y-intercept, x is 0. So let's do it just like we did in the last problem. So in the last problem we said y is 0, which means this guy goes away, and I see negative 2x equals negative 5. So let's see, divide both sides by negative 2. You didn't tell me we were going to have fractions. All right, we're going to come back and address that guy here in just a moment. I'm just going to ignore him for right now. For the y-intercept, x is 0. So if x is 0, that means we are left with this guy. 5y equals negative 5. Divide both sides by 5. Y equals negative 1. All right, that's a little bit easier to stomach. We've got 2 points, and 2 points is really all we need to uniquely determine a line. So let's plot these guys. Oh man, we got to come back to the fraction. Well, remember this. If I look at 5 halves, that is the same thing as saying 2 and 1/2 when I convert that improper fraction into a mixed number. Right? So that 2 1/2 means I'm going to be right in the middle between 2 and 3, like that. And my y-intercept is 0, negative 1. And this doesn't look too good for us. Looks like we're going to run into some issues if we try to either get more points by using the intercepts, or if I just try to throw a straight edge on there and try to connect the dots. Because these points are so close, I can be off by just a little bit. In the middle, it's going to be fine, but on the edges, it's going to be really off. So instead of doing that, let's try to calculate the slope by taking the equation in standard form and converting it to slope-intercept form. So, just as we've talked about, get the y by itself. So I need to move the 2x to the other side. So 5y is equal to 2x minus 5. And then to finish getting y by itself, divide everything by 5. So y is equal to 2/5 x. 5 divided by 5 is 1. And from here, it's really not too bad because we see that our slope is that coefficient of x. That's going to be 2/5. And we see that we have the same y-intercept of 0, negative 1. So it's nice that we did things 2 different ways and we still got the exact same response from that. So let's use these guys to finish graphing. Let's use the slope of 2/5 to get more points. So slope of 2/5 is positive, which means the line is going to be going up from left to right. So up 2 units and over 1, 2, 3, 4, 5. I can go up 2 again, and over 5 is going to be just off the grid a little bit. Let's reverse this. Down 2, to the left 5, down 2, to the left 5. Now you notice that I skipped this guy as we were going through using the slope to find extra points. But this point ends up being the midpoint between these two guys right here. So we can get extra points by finding the midpoint. So even though I'm going, let's say, down 2 to the left 5, if I do half of each of those, that's the midpoint. So half of 2 is 1, and half of 5 is 1, 2 1/2. Instead of going down 2, we do half of that. Half of 2 is 1, half of 5 is 2 1/2. So we can get these extra points to help us line up everything and just add an extra level of accuracy to our graph. Just like that. So what do you think? Hopefully that's okay. So if you get into a tough situation where you have a fraction for one of your intercepts, solve your equation for y to find the slope. And then use that slope from a nice point. Hopefully you have at least one nice point that has nice integer coordinates, and then build from there. So here, like we said, going up 2 over 5, up 2 over 5, and so on. Okay? All right. Some other things that we can see when it comes to graphing linear equations. We talked about how in standard form you can't have both the x and the y coefficients to be 0, but what if one of them were equal to 0? What if I have this and I say y equals 5. Now when I say y equals 5, you see there's no x term. So what does that mean? Well, think about this if you were to try to make a t-table of values to get an idea about where you are. If I plug in -3 for x, there's no x here. All you have is y equals 5. If I plug in 0, there's no x to accept that value, and you're left with y equals 5. If I plug in 7, there's still no x, and you're still going to be left with y is equal to 5. And so we can use these points to get our graph. So you've got -3, 5, 0, 5, and 7, 5. And what we see here is that we have a line. Of course, it's supposed to be a line, but more importantly, it's a horizontal line. If I were to look at what's going on here, this ordered pair has the coordinates -3, 7. -3, 5, excuse me. This is 0, 5. This is 7, 5. So what's staying the same in all of these? Y is 5. And that's why we have a horizontal line. So every point that is on this horizontal line has a y value of 5. Every point. If this line were to deviate whatsoever, if it were to go up or if it were to go down, then the y value would not be 5 anymore. It'd be something different. But this equation says that y is 5. Y has to be 5. And so here's something that we know about these types of equations. For a horizontal line, which is what we have, horizontal lines have a slope of 0, and they take on the form y equals b, with the emphasis here that there is no x term whatsoever. So when all you have is y, you are going to have a horizontal line. And you get y by itself, and that tells you where the horizontal line goes. That's all we have to do for that. Now on the flip side of that, you might be thinking, well, what if it's not y equals, but it's just x equals? I bet you already know the answer to that. Alright, so if I say x is equal to -4, if I were to make a t-table of values, I'm going to kind of run into trouble here. Because when I say that x is -4, that means x can't be anything other than -4. He's stuck there. Whereas y, who's not even here, y can be whatever it wants to be. Y could be 0, y could be 4, y could be, -6. It doesn't really matter. All that matters in this equation is that x is -4. That's it. And when you start to plot these points, you get -4, 0 right here, -4, 4, and -4, -6. So you get a vertical line like that. And just to make the connections back with what we saw on the previous graph, okay, you see that you've got something going on here. So this was -4, 4. This was -4, 0. -4, -6. And so you see the x coordinate doesn't change. It stays the same. If this vertical line were to tilt one way or the other, then x would no longer be stuck at -4. It'd be something else, which would then be a totally different equation. Now, forgot to mention something on the last graph. I said it, but I didn't explain it. So let's talk about this. On the last graph, we talked about how a horizontal line has a slope of 0. But why is that? Well, if you think about trying to calculate the slope right? So the slope is the ratio of the rise to the run. As I go from point to point, let's talk about what my rise is. From this point to that point, I had a rise of 0 units. I didn't go up or down, I just went left or right. My run is to the right 7. And so what we have is that our slope is equal to 0. 0 divided by 7 is going to be 0. So for any horizontal line, it's not going up, or excuse me, it's not going up and it's not going down, so the slope is going to be 0. What about vertical lines? Well, their slope can't be 0 because they don't even go in the same direction as the horizontal line. Check this out. Let's try to calculate the slope just like we did before. The slope is rise to run. And from this point to that point, I have a rise of 4 units, but my run, I didn't go left or right. I stayed right there. So my run is 0. And as we mentioned before, when you divide by 0, you come up with an expression that is undefined. And that's what we have here. When we talk about vertical lines have an undefined slope. And they always take on the form x is equal to just a number. And kind of like what we said before, there is no y term here. So if the y term is absent, you're going to have a vertical line. If the x term is absent, then it's going to be a horizontal line. Doesn't seem to be too bad, right? All right. So if I gave you this and I say 3x minus 15 is equal to 0, and we need to graph that. One of the first things that you should notice is that it doesn't contain x and y, it just contains x. So if it just contains x, we just got done saying how that's going to be a vertical line. But for us to figure out where the vertical line is, we need to solve this for x. So let's add 15 to both sides. 3x is equal to 15. And then divide both sides by 3. X is equal to 5. So that means it's x equals 5, it's just x, and it should be a vertical line located at x equals 5. So you could start right here and really just put a few points. Doesn't really matter where they are, as long as they are where x is equal to 5. So when we graph the line, we have a vertical line, and every ordered pair is going to have an x coordinate of 5. The slope is going to be undefined. And there we have it. Okay, so that's basically the review we have for graphing lines. What we're going to be talking about tomorrow might take a little bit longer. We're going to be looking at writing equations of lines. So if I give you the slope and I give you a point, can you write an equation in either standard form or slope-intercept form that would be that line? We're going to look at parallel and perpendicular lines as well, and see how all of that figures into writing equations of lines. And this is an important concept because a lot of things that we have in the real world are based on a linear relationship. And so if we have two data points on that, then we can take those guys and extrapolate that, find the slope, and find an equation for that. So if you say, what's it going to be in 100 days, or if I work 56 hours, you can use that linear model to find out what your answer is. All right.